screen. No. We'll do it like that. Hi, everyone. I'm Adrian. I work at Pydantic, and I'm going to be presenting today on adaptive filter execution in the Parquet Decoder. So Pydantic is also an observability platform. We also build our data stack on top of DataFusion. So we use DataFusion to run essentially arbitrary queries from users. These queries are very varied, and so we need to essentially make our system fast for a wide range of query types. In DataFusion, there's an option called push down filters on, and it makes some queries a lot faster, some queries slower. I'm essentially calling it a per query lottery. So you have to statically decide, like we Pydantic have decided we turn it on by default for all queries, and that makes some queries a lot faster, but it does make some queries a lot slower. And DataFusion itself as a project has been contending for years now with do we turn this on or do we not turn this on? And we can't turn it on because it'll regress some queries but make others faster. So the pattern that you end up seeing is essentially when you have push down off, you download the entire data and filter it in memory. And when you have this push down on option, you do more granular, smaller IOs and more granular, smaller CPU works on a per filter basis. But you download less data overall, you might be more efficient, but you do less bulk work. So what that looks like with queries is this is an example of query where this push down option is a big win. Because what's happening here is we're going to select off the columns, but we have what turns out to be a very selective filter. This is from ClickBench. It's Q23. They essentially have clicks on websites. So one of the columns is a URL. A small fraction of the clicks are on Google. I don't know what percentage it is, but let's say like 5% or something. But the point is, with push down off, what you do is you download the entire data set, the entire whole thing, because you're doing select star. So you download an entire whole data set, and then you filter for a URL like Google. And you pay the latency of downloading all of that, all the network bandwidth, decoding all of that stuff for every single column. With push down on, you first download the URL column, you filter that, you come up with some mask, and then you use that, and we try and be as efficient as possible to select only pages and stuff like that, but we download only a small subset, let's say, again, 5% of the rest of the columns. Where this push-on option loses big is a query like this, where there's a filter that's not selective. Like in this case, maybe there's 1% of search phrase is empty. Most of the rows have a search phrase. And the queries we're actually selecting, the columns we're selecting, search engine ID, is a lot smaller than the search phrase itself, and we're also selecting search phrase itself. So this is, I think, I can't see my notes here, but I think this is Q21. But the point is, here it's much more efficient. Just download the search engine and search phrase column and filter out the couple of rows that have empties in memory. If you do the pushdown version, the query ends up taking about twice as long because you first download the search phrase, you filter it, turns out you filtered out 2-3 rows, and then you go and you download all the rest of the columns, and on top of that you're paying extra compute costs to apply a filter and all this kind of stuff. So given there's two extremes, some where this is much faster, some which is much slower, and it varies on a per query basis, what I would like to propose is that we adopt an adaptive system that decides on a per filter, per query basis, per dataset basis, which one of these two options to run. So it's not like all or nothing, like you have to set it for every single query or none of your queries. You let the engine decide adaptively which one to choose. So the basic idea is you use some heuristics for initial placement. And those initial heuristics right now are how the page index prune things, which for some filters gives you a very good idea of how that filter is going to perform, as well as like how large the column you're filtering is versus the rest of the projection. And so it's heuristic based, but you choose where you start. Then as the query executes, you measure, essentially how selective is this filter, how long does it take to compute, how contiguous are the masks of selections or non-selections, which matters for page pruning and other reasons. But there's a couple of metrics that you track for each filter. And then at certain boundaries, like row group boundaries within files, you get to decide, do I move this filter to the row filter level, which is this download only this column, evaluate this column, download the next column, evaluate this column, or do I move this filter to the post scan level where I just pull the data in bulk and do the more brute force but more contiguous I/O and compute version of this. And there's a special case for these dynamic filters that were being mentioned in the previous talk. Sometimes they're very effective. Sometimes they end up being just wasted work. But since they're somewhat optional for some filters, you can actually even use these statistics to just drop them altogether and stop evaluating them. So the rest of the talk is going to focus on results. So I have essentially three categories I'm going to be comparing. Main, DataFusion main with default settings, which is push down off. DataFusion main with push down on, and this change. So this is Q23, which I showed earlier. It's that URL like Google, and you can see DataFusion main with push down off is very slow because I said it has to download the whole data set filtered in memory. DataFusion main with push down on is very fast because it does the most efficient thing. This change is almost as good as push down on. There's some overheads. It might make the wrong decision for a little bit, but then adapt. But it's almost as good. And overall, on the entire ClickBench benchmark, it ends up kind of getting the best of both worlds because it's faster on this Q23 late query, but it avoids a lot of slowdowns that the current hard-coded pushdown on gets with other queries like the Q21 one I showed. The story is pretty much the same for all of the other benchmarks. Essentially, we pay a small price for some queries where we might start with the wrong heuristic, but then adapt quickly. But we avoid the big penalties where we are doing the wrong thing for the entire query. Yeah, TPCH, similar thing. It's interesting if you start looking at introducing latency, like if you're talking object storage instead of an SSD, it tends to amplify the picture because if you make the wrong choice of going with the filter pushdown on version where you're doing the smaller IOs and being more selective and technically more efficient, because you have to pay even bigger latency costs on object storage, that just amplifies your losses. So I've been implementing various versions of this over time. The trick has been to find the right heuristics, the right points to adapt. There was recently APIs added in Arrow that make it easier to essentially switch how you're doing the decoding between one record batch and another. And I think this work is now in a place where we could move forward within DataFusion. There's some stuff that I think will help even more, like being able to adapt between row groups, because there's some like TPCH is at scale factor 1 is a single row group for the entire files. So essentially, whatever your heuristic decision says at the beginning is what you got. And so being able to, for data sets like that, or like DuckDB tends to write single row group Parquet files, no matter how big they are, being able to adapt mid row group. At some point, you say like, okay, this row group is huge, and I have to pay some price to change my decision of data decoded and have to throw away. But it becomes worth it if you're sure enough about your decision and there's enough data left to scan. We also have other ongoing work to better balance between partitions, because one of the complications of this change is, although logically we're not changing where execution is happening, because we ended up moving filter evaluation into the Parquet scanner, it's not behind one of those repartition nodes we saw before, so it's more susceptible to data skew. And there's changes we're already making in the Parquet decoder to essentially split up be able to share work across partitions in the Parquet scan stage that would make that much better. But the end goal is, we can merge this change, and we're strictly better than main with pushdown on. And then if we are able to, maybe with some of these changes, get it to the point where it's always better than main with pushdown off for every query, then we can turn this option on by default. Questions? like you're surprised that the push down on is such a penalty on, let's see, like this one, for example. So in this one, the push down on is a lot faster on SSD in Q23. And this one, push down on is a lot slower. And this one is, I think this one is because of dynamic filters that aren't selective enough. So you're paying a bunch of extra CPU cost to do hashes and probes. Like this is the thing that's difficult. It varies by query, by, whatever. Even on SSD though, the filter push down version sometimes you end up paying a lot more cost in compute of essentially computing a mask where you removed one row and now you're doing all this overhead of like, selectively reading some pages and like applying this mask and all this kind of stuff. Whereas like it would have been much more efficient to just read the whole thing and filter out one row at the end and not trying to like do it iteratively and that sort of thing. So there are real compute costs as well as IO costs. It's a mix of them. It varies per query. Yep, and it actually does that. So the current push down on has a version of that, and it's a heuristic based on just the size of the columns in the filter. But this uses the same heuristics it uses to decide where to place the filters, which order to evaluate them in. And there's some games I haven't even gone into playing with like even on the once you have all the data in memory, you could decide to evaluate filters one at a time and use the mask to apply to the next one, or you could evaluate them all together. And like, there's some other games you can play there. But yes, essentially, you can use these same statistics to decide how to lay out your compute in the most optimal order. Yeah, that's a really good question. So, I mean, the way this ends up looking like the selectivity stuff, it's like a hash map of like filter expression to some statistics on it. So you can imagine a world where like this is right now because in DataFusion there's no like central store of anything. It's like you open a Parquet file and you start from scratch and you start accumulating these statistics as the query executes. But you can imagine like in an engine like Logfire or Datadog or whatever, you might have some central metadata store which keeps track of global for this tenant for this query they run all the time. We know this filter super selective or something, so you can essentially use those statistics to force initial layout, right? You say like this filter is always going to start as a row filter because I know it's super selective, or this filter, we're always going to start as not a row filter, and you could, I don't know, use only that, or you could mix and match that with like you seed what happens at runtime, but then you still adapt at runtime. Right. Thanks, everyone.